Alright, back to logs. Before we can get into logs, remember I told you that logs are actually exponents. If you go into our My site, here where it says exponential and log functions, what I did is I put a document into here, rules for exponents. These are rules that you already knew. These I think are introduced in grade 9 and grade 10. If you look through them, you'll start to recognize them. I mean, for example, a to the power of 0 is 1. These are all rules that you already knew. Okay? And just like there are rules for exponents, there are going to be rules for logs. So let's take a look at some of those. Okay, first of all, there's the product law. If we have log base b of something multiplied here, x times y, we can split that up into two logs, log base b of x plus log base b of y. And if you think about that, should kind of make sense, because when we multiply exponents, we add their powers. So what are we doing here? We're actually adding their powers. Okay, remember I told you the log is an exponent? Okay, the same with quotient. What was the rule for when you're dividing powers out of the same bases? We're going to subtract the argument. Okay, and power to a power, what's the rule there? Well, that we would multiply the exponents. So we're going to just take this k and move it as a coefficient and multiply it times the log. Okay, those are the rules. Let's try and use them. Okay, so here we see log. By the way, what are the bases? It's not written. These are base 10. You don't need to write that in there, but just keep that in mind. So if we have bases that are the same and the two logs are added, this is the same as saying log base 10 of 56, because that's what 8 times 7 are. That's the first log. Okay, when I see this one, this is the same as saying log of 2, and instead of having that 5 as a coefficient, you can write it as a power. So we could say this is log 32. Okay, by the way, that's base 10 as well. And then what is this one? Well, they're both base 10s, and when we see subtraction, that's the same as writing it within the same log as division. So we get log base 5. Okay, and sometimes we can use these rules to help us evaluate. So if you look at this one, and we put that half back on the exponent, you get log of 10. Now what does this mean? This is a base of 10 here, and this is saying 10 to what power is 10? This answer is 1. Okay, because 10 to the power of 1 equals 10. Alright, let's try this one. So this is going to be log 6 to the negative 2, which is log 1 over 36. And this we can't evaluate. Okay, so here's a common question. Write as a single log. So we're going to use our log laws to try to condense this to just one log. Okay, so the first thing I know is I could put this 3 back on the y. Alright, and then I see one exponent added to another one. So this would be x times y cubed. Okay. Let's try this one. We're going to write as one log. All right, I see these two added, so let's add those two. X times y squared. And then I see subtract, so I know I'm going to divide this one. Okay. Well, this is a trick that I know will probably show up on a test. I've seen this before on an exam. So if we want to condense these, the problem is this one is not a log. All right, but we can change it into a log. So watch this. So if I want this to equal 3, but I want this to be a log, I'm going to write this. Why did I write that? What does this equal? Well, this is saying 2 to what power is 2? Well, it's 1. So what I've done here is I've gone 3 times 1. What's 3 times 1? It's still 3. I haven't changed this question at all, it just looks different. Okay, and now that I have two logs with the same base, and it's subtract, I'm going to have 6 divided by 2 cubed. Okay, so that can be simplified to log base 2 3/4, because 2 cubed is 8. Okay, so that's a common question where well, I shouldn't say common, but it is maybe a trick that you'll see once in a while, where you have to introduce a log and you want it to equal 1. Okay, so you can just use base with the same number in the argument. Okay, let's change this to a log. So I see some that are added. Okay, so I have log, and then these two are subtracted. Now, careful with this. I can't separate this. This is not x times 1. This is just log of x plus 1, so I can't change that. Okay, but in the denominator, I see y minus 2 cubed, and I see z squared. Okay, since I'm subtracting this log, I'll divide it here. Since I'm subtracting this log, I'm dividing it here. Okay, one more. So what's being added? This is positive, this is positive. Let's put those on the top. X to the power of half, a to the power of 5. This one is subtracted, this one is subtracted, so I have y squared, z to the 1/7. Okay, so same thing here, but exactly the other way. So this time they want us to expand. Okay, I know it doesn't say that. It says write each expression in terms of log a, b, or log c. Another way of writing this is to say expand. Okay, so I'm going to have log a minus log b squared, except I can put that squared as a coefficient. Okay, let's try another one. Log a squared, wait a second, I'm going to put that squared here, plus log b to the 1/3, except I'm going to put that 1/3 in front, and then minus log c. Okay, what does root a mean? This is the same as a to the power of half. So I'm going to write log a to the power of half. No, I'm going to put the half in front. Plus 4 log b minus 3/2 log c minus 7 log d. Okay, same idea. I know this looks like two separate things, but because of the brackets, this is one term. Okay, so I'm going to write 2 log x plus 1 minus 3 log m plus 1 minus 4 log n minus 3. Okay, so those are the log laws, kind of practice using them. Let's see how to use them to actually evaluate. Okay, so if you just had this, 9 to what power equals 72? Well, that's impossible. There is no power of 9 that equals 72. So this can't be done the way it is, but maybe we can condense this into one log, because they're both log base 9s. Okay, so I'm going to write log base 9, and this is positive, so I'm going to write 6 cubed. This one's negative, so I'm going to divide by 72. Okay, so this is log base 9 of 216 divided by 72, which is log base 9 of 3. And then 9 to what power is 3? The answer is half. Okay. Let's try this one. So again, 4 to what power is 6 doesn't work. 4 to the power of 3 doesn't work. Okay, so let's write this as 1 log. They're all base 4, so I'm going to have 6 squared. And then this one is plus, I'm going to go times 12. This one is minus, so 3 cubed. Okay, now that looks pretty ugly. Let's see if we can simplify this a little bit. Remember, this is a non-calculator question, so I don't think I want to multiply that out. I'm going to leave this as 6 times 6 times 12, and I'm going to leave this as 3 times 3 times 3. And the reason I'm doing that is I can simplify now. Okay, what's 6 divided by 3? It's 2. What's 6 divided by 3? It's 2. What's 12 divided by 3? It's 4. So this allows me to simplify this without using a calculator. 2 times 2 times 4 is 16. And 4 to what power is 16? 4 to what power is 16? 2. Okay, so hopefully that makes sense to you. That's a lot of material actually. There's a lot to learn in there, so I'm going to give you a little bit more practice questions. Since logs are completely new, I really want to emphasize to you that you should try all of these questions so that you're not surprised when you see them later. Okay, so that's the textbook. I also have a handout called the Summation of Logs. Okay, and there are parts A, B, C, D, E, F. If you can do all of those sections, I expect that there's going to be some questions. There are definitely some tricky questions in there. Don't be afraid to text me using the chat or to email. Okay? Good luck with those.